Hello class, this is Calculus Part 3. In this video we'll be looking at an introduction to limits. Limits, in its simplest understanding, is the resulting value of a function as we move one variable closer and closer to a target value. This is a very basic understanding, but it'll be enough for our level. In actual fact, in this same video we will be further developing this definition. So let's get into it. We applied this definition very loosely in the previous video. In the previous video, we saw how we could calculate the gradient of this tangent, this one here in orange. We could calculate this gradient by moving this point closer and closer to the point T. And each time we move it closer, we calculate the gradient again and again. So here's one repetition. We saw the gradient here of this secant was 2.5. We move the point P closer and repeated the calculation and saw that the gradient was 2.1. We move this point closer again and calculated the gradient again of this secant and saw that the gradient was 2.01. We moved it even closer and saw that the gradient was 2.0001. Okay, so this idea of moving something closer and closer to a target value is a limit. So in this instance, using the gradient formula, that's the function that we're operating on, we moved closer and closer, that's a limit, the point P, x2, y2, that's the variable, to the tangent point T, that's our target value, and this resulted in a gradient calculation of m equals 2. Obviously here, the gradient was not 2, it's 2.0001, but what the limit is simulating is what if we repeated this process infinite number of times. So we keep moving this closer and closer. Okay, so obviously we don't have the time to repeat this infinitely many times, hence why we simulate it using a limit. So the notation for this is as follows. In this example, our gradient is the function we're working on, and we moved P, which is y2, x2, closer and closer to the point T, y1, x1. So visually, this means that we're calculating this secant, the gradient of the secant, sorry, and we repeatedly calculate that gradient as we move it closer and closer to T. Eventually, the point P will become T, and at which point we have the tangent, which shows that the gradient at that point will be 2. This, however, is an improper use of limits, as a point P and T is not a variable. We're just kind of illustrating what's going on. From this, we can better define and understand the use of limits. Okay, at first this will be very confusing, but I'll explain to you what's going on in a moment. So the limit as x approaches a of a function is equal to the limit as x approaches the left side of the function, so this is called a left limit, should equal the limit as x approaches the right side of the function, this is the right limit, and it should equal the function value of f of a. Again, this is still very basic, but slightly more accurate than the definition we just saw. So in words, we can say that the limit of a function, so the limit of a function is equal to the function value when approached from the left or the right. So here's a demonstration of this. Here is the limits. So we're going to evaluate the limits as x approaches 2 in this function. So in this example, we're going to approach 2 from the left. So starting from 1.5, we substitute 1.5 into the function, gives us 4. We move closer to the value of 2, so closer than that is 1.8. We substitute this into x, which gives us 4.6. We substitute 1.9, which is closer to the value of 2, into our function x, gives us 4.8. Then we move it closer and closer, each time getting closer and closer to the value of 2. As you can see, if we keep repeating this, the limit as x approaches 2 from the left-hand side is equal to 5. If we do this from the right-hand side, so starting at 2.5, all right, and we're going to repeat this process again. 2.5, substitute into here, gives us 6. Moving this value closer to our limit function, our target of 2. So 2.2 is closer to 2, gives us 5.4. Moving again closer, 5.2. Moving again closer, 5.02. And moving it again even closer, 5.002. As you can see, if we keep repeating this process, eventually we can see that the limit as x approaches 2 from the positive side, so from the right-hand side, it's equal to 5. So far, these two are equal. Whoops. And lastly, we can simply just substitute the value, so f of 2 into the value here. Here we can see that it's equal to 5 as well. So the limit as it approaches from the left, as it approaches from the right, and the value itself are all equal. Therefore, we can say that the limit as x approaches 2 of this function is equal to 5. Looking at this visually, what this means is as x approaches 2, so let me simulate this. So limit as x approaches 2 from the left-hand side, so going this way, the function is approaching the value of 5. If we do this from the right-hand side, so the limit as x approaches 2 from the positive side, so going from this way, we can see that the function value is approaching 5 as well. And if we substitute x equals 2 into the function, we simply just get f of x equals 5. So a limit is actually approaching from both ends, right? And substituting at the same time. So for simple expressions such as polynomials, limits can be evaluated by substituting the function values. So in this case, these are all very simple expressions. We can calculate these limits just by substituting them. So for this, the limit of this is 3 times 2 plus 1. It's going to be equal to 6 plus 1, 7. So the limit of this is 7. This one, it's negative 3 squared minus 2. That's positive 9. That's negative 9 minus 2. So this is negative 11. So the limits of this is equal to negative 11. As for this one, substituting 0, so it doesn't always have to be x. It can be whatever variable that we want. So in this case, 0 cubed plus 5 times 0 squared plus 6 times 0, well, that's all just equal to 0. So the limit of this is equal to 0. So this is what a limit is, right? So it is pushing a value closer and closer to a target that we want. Hopefully that gave you an insight into limits, even though it's a basic one. We're now going to move into answering the question, what is the gradient of a function or a curve? Hope to see you in the next video. Best of luck.